Kia ora, hello. Concave mirrors are used a lot in industry and in astronomy. They're also a big chunk of the year 12 physics curriculum in New Zealand. When I look at how they're built, two types, and look at three very handy rays. When you're dealing with light, jillions of rays. A jillion is bigger than a zillion, and gigas are 1,000 million jillions, so there's a lot of rays. Of all of those, we choose three, because three rays will help us figure out what's going on. First of all, here's a photograph of a piece out of Dave Housden's workbook. The spherical ones are the cheaper type. They are made from a part of a sphere, a hollow glass sphere, silver coating, and then light is bounced off that. And the more expensive type are parabolic in nature, and they're very expensive and quite tricky to deal with, but they make a better image. You get what you pay for. We've got three key places. We've got the center of curvature, because it's a sphere. We've got the pole, which is the middle of the mirror that of the section that we look at, and the focal point is where all the rays that come in parallel will go through that place. So there's three places. The second are two lengths. First of all, the focal length and the radius of curvature from the center, and it's this way as well. That's for convex. So the focal length and the radius, and interestingly enough, the focal length is half of the radius. That's because of angle and angle out stuff. Some handy rays I'm dealing with concave mirrors today. If you look at the pole, at the middle of the mirror, at the pole, that little chunk there will be square on. So therefore, any ray coming in will be bounced out at the same angle. Second one is any ray coming in parallel will be bounced out through the focus. And it doesn't matter where it comes in parallel, anywhere coming in parallel, that's useful. Plus, these paths are reversible, so any ray coming in through the focus in any particular direction will be bounced out parallel, and this picture shows that quite nicely. So we talked about what they are and how they're built, two types, spherical and parabolic, and looked at three very handy rays amongst zillions and gillions and jillions of them, gigajillions, to pin down what's going on, because they're going to be useful to find an image. Cheers, everybody.